Type of structures. See, you already know these things. How we are classifying the structures? Anyone? What are the various type of structures? You already know. Type of structures. What are the various type of structures? We already discussed. Yes. Perfectly correct. Yes. Super and substructure. That's also correct. The part of the structure above the ground is called superstructure. Below the surface of the ground is called our substructure. Yes. Perfectly correct. Saksham, Sudha, determinate and indeterminate structure. There is one basis of one type of classification, and Sakshan Kumar is saying that skeletal surface massive. That's also perfectly correct. Yes, on the basis of material also we can classify like reinforced concrete structures, steel structures, different type of structures are there. Yes, you people are perfectly correct. We are starting with the type of structures like this, or we are classifying the type of structures like this. Yes, what are the type of structures? We will classify the structures like this. First one is our skeletal structure. This is one of the important classification. I have to mention 2-3 important points here. That's why I am taking it as a first one. Skeletal structure. Second one is our surface structure. Third one will be our solid or massive structure. Both are same. Solid or massive structure. Skeletal structure, surface structure, solid or massive structure. Let's discuss one by one. Okay. First I am going to take the first one, skeletal structure. Anyone, can you tell me what is a skeletal structure? What is the meaning of skeletal structure? That was our first one. That is our skeletal structure. What is the meaning of skeletal structure? Anyone? Based on the type of materials, we can classify the structures like reinforced concrete structures, steel structures, timber structures, like that. Okay. We are not going for that actually. This is actually one here. I want to discuss some 2-3 points here, right? Which can be idealized into a series of straight lines and curved lines. Okay, it's correct only. Only one dimension is considerable. Rajat, okay, you are perfectly right. I am going with that. Shavbas, framed, okay, you are right. See, what is a skeletal structure? I'll discuss or I'll explain it in a different way. See, when I draw a simply supported beam, I have drawn a simply supported beam just now. When I draw a simply supported beam, I draw a beam like this. Right now, I fold out this as a representation of simply supported beam, right? And it did like this is our length of the beam. But when you see the real case, a beam is actually a 3-dimensional structure where you will have length, breadth and height. It's a 3-dimensional structure. You will be having depth there, you will be having breadth there, and you will also have length will be there for a beam. Correct? But when I told you to draw a beam, which dimension did you consider here? Which dimension did you consider? You considered only one dimension, that is the length of the beam. Alright? When you compare the depth, breadth and length of the beam, if you consider the depth, breadth and length of the beam, which was considerable? As our Rajat said, which was considerable? Yes, length of the beam was considerable. Or I am going to give the definition of skeletal structures like this. When one dimension of the structure is predominating the other 2 dimensions, we will call that as a skeletal structure. Got the point? When one dimension of a structure is predominating the other 2 dimensions, we will call it as a skeletal structure. In a beam, when I consider a simple supported beam, the length of the beam was predominating the breadth and depth. So we are going to go with only the length of the beam, or the length of the beam was predominating there. It can be considered as an example for our skeletal structure. I hope it's clear. You can write it when one dimension, it can be a length, it can be height, it can be breadth, it can be depth or whatever may be. If one dimension, any of these dimensions is predominating the other 2 dimensions, we are going to call that a skeletal structure. simply supported beam and example. If you want more examples, this can be our example number 1. You might have heard of the structure arches, right? This is our arch. You might have seen structures like this. This is our arch. This is an example for a skeletal structure. In which respect it predominating shell. Okay. See if you can see your beams there. I cannot show you a beam here, but if you can see a beam, you can see there a beam will have 3 dimensions, right? Breadth will be there, depth will be there, and length will be there. The which dimension is predominating there? Length of the beam will be predominating. That means one dimension will be predominating, the other 2 dimensions we are going to call it as a skeletal structure. You will understand or you will differentiate it when I discuss about the surface structure. You will get the concept. Just have some patience. We will discuss all the concepts. Okay. If I consider, coming back to our point, this arch can be considered as our skeletal structure. Then some of you were saying that frame, right? So some of you are saying that building frame. Yes, you can consider or you can call that also as a skeletal structure. This is an example. This is a frame which is called a plane frame. You will see, we will discuss with these structures in the coming classes. This is our plane frame. If you want to make it as a building frame, you have to have different stories. This is our support, and we have a support here also. This is also a support, right? I am having different stories here. This is our story number 1. This is our story number 2. Okay. So this is a frame structure actually. I hope it's a clear figure. Sorry for this bad figure actually. You will be having vertical members here and you will be having a horizontal members here. If you see, if you want to explain this portion of this vertical member or the vertical portion of this frame is called columns. This vertical portion is our columns. And this vertical portion, this portion is called our beams. It's a combination of columns and beams. That means a frame structure. In a column, which dimension is predominating? In a column, which dimension will be predominating? Yes, in a column, Isha, you are right. In columns, which dimension will be predominating? Yes, height of the column will be predominating. Yes, you are right. Perfectly right. Height of the column will be predominating. That means in a column there will be height, there will be breadth, there will be depth also. Length will be there, breadth will be there, height will also be there. But when we talk about a column, we will be mainly focusing on height of the column. One dimension is predominating the other 2 dimensions. We will call it as a skeletal structure. Column here, coming to beam. In which dimension is predominating in a beam? Length of the beam is predominating there. In a column, height of the column will be predominating. When the one dimension is predominating the other, I am going to call it as our skeletal structure. I hope it is clear, right? Yes. Coming to our surface structure. Our skeletal structure is over. Coming to our surface structure. I am just rubbing these things off. I hope you have noted it down. This is our simply supported beam. This is an arch, and this can be our frame structure. There is only columns are there, there is beams are there. I am not considering our slabs now. Only frame, that means only slabs, only columns are there, only beams are there. Fine? Okay. Right. Then coming to, I am just moving on to our surface structure. I hope you have written it down. I am going to surface structures. See, we were discussing about the type of structures, and we have completed like skeletal structures. We discussed about skeletal structures. And now we are moving on to the next type of structure, that is surface structure. I hope you may be already knowing or you got the concept right. I hope you are good. Yes, I hope you are getting the concepts. See, we discussed about the skeletal structures. In skeletal structure, only one dimension was predominating the other 2 dimensions. Then we call it as a skeletal structure. I gave you an example, like beam is an example, like column is an example, or some other like frame structure is an example. Maybe arches is an example. This is all are the example for our skeletal structures. Now we are moving on to the next concept, that is our surface structure. You can write down the second topic, that is our surface structures. Surface structures. Okay. So what is surface structure? I hope you already know this. We have discussed about skeletal structure. There is only one dimension was predominating in skeletal structure, so in surface structure. Then what will be skeletal structures? Anyone? What will be skeletal structures? Anyone? So it's surface structures. I was asking about surface structures. We discussed about skeletal structures, and now we are just moving on to our next topic, that is surface structures. I am asking you, what will be surface structure? We have completed our skeletal structures. Okay, but wall is not a load bearing structure, Aditya. It's actually usually it's a partition, right? Yes, you're right. Yes, Raushan is saying that when two dimensions are considered. Yes, when two dimensions are considered, or when, see, if you consider your slab, the thing or the part of the structure you are seeing above your head, that is our slabs, that is roof slab and floor slabs. You can see there, when we discuss about a slab, you will be discussing about the length of the slab, you will be discussing about the breadth of the slab. There two dimensions are predominating, or the third dimension, whatever it may be, here in the case of slab it is depth. There the depth is negligible compared to the length and breadth of the structure. When we consider a slab, the length and breadth is predominating the third dimension. We are going to call that as a surface structure. I hope it's clear. You can write down when two dimensions, it can be length, breadth, depth, or length or breadth, whatever it may be. If two dimensions are predominating the other dimension or the third dimension, we are going to call it as a surface structure. Write down. You can write it down. When the two dimension, when any two dimensions in a structure is predominating the third dimension, we are going to call it as a, or we will call it as a surface structure. Surface structure. I hope it's clear, right? Yes. Can you give me some examples for these surface structures? Anyone? Amit, can you give me some example for surface structures? A road is actually a completely different concepts. We are discussing about structures here. Okay. You can talk about the buildings. You can talk about bridges, etc. Okay. Yeah, fine. Yes. Amit is saying that dome. Okay, perfectly correct. Abhay, slab. Yes. Dhruv, slabs. Exactly correct. Slab, floor slab, deck slab. Okay, fine. That means, example, you can consider slab as a surface structure. Slab is a surface structure where length of the slab and breadth of the slab is considerable, and the thickness of the slab can be neglected. One dimension can be neglected, or other two dimensions are predominating the third dimension. So we will be calling it as a surface structure. Our building slab, it can be a roof slab, it can be a floor slab. You can call it as a surface structure. Coming to, someone was saying that, I hope I forgot your name actually. Yes, Amit Verma was saying that dome, or I hope you are talking about a structure like this. Right? The thing or the type of structure you can see above the most console, right? Yeah, this is a surface structure. The name of it is dome or shell structure. You can call it as a shell structure or a dome, which can be considered as a surface structure where the thickness of this structure is negligible compared to the other dimensions. We are going to consider it as a surface structure. It appeared in one exam. I think it is RRB JE exam. It was a question in one of the exams, RRB JE. The question was like this: shell is a type of, option A, that was surface structure was there, skeletal structure was there, massive structure was there, then some other options, none of the above was also there. Then shell is a type of what kind of structure? It is a type of surface structures. Shell or slab, this can be considered as our surface structures. I hope it's clear. The all other two, so the two dimensions are comparable, or two dimensions are predominating the third dimension. We are going to call it as a surface structures. I hope it's clear. We are moving further. So the third one is actually not that much important, but still I wanted to cell. It's not cell, actually shell. S-H-E-L-L. Shell. Okay. S-H-E-L-L. Shell structure or dome. Both will convey the same meaning. Right? Yes. Fine. Then after that, after surface structures, we will be moving on to the third one. That is our solid or massive structure. Third one here will be solid or massive structure. See, what is this solid or massive structure? I know you got the concept, right? We were talking about skeletal structures where one dimension was predominating. We discussed about surface structures where two dimensions was predominating the third dimension. Then tell me what will be our solid structure? Anyone? Which cannot be idealized to plane or curved surface. Okay, top portion of a mosque. Yes, that was an example like for a shell structure. All the three dimensions are comparable or considered. Yes, perfectly correct. Yes, dam is an example. Shahbaz, you are right. That means we will call a structure solid or mass structure when all the dimensions, it can be length, breadth, thickness, whatever it may be, all the dimensions are comparable. Then we are going to call it as a solid structures. Please write it down. All the dimensions of a structure are comparable. All the dimensions of a structure are comparable. We are going to call it as solid or massive structures. Yes, dam. Yes, you can consider dam as an example for our solid or massive structure. Example for solid and more massive structure. You can consider dam as an example. Yes, dam is an example for a solid or massive structure where all the dimensions are comparable or where all the dimensions are considered. Nisha, you are right. All the dimensions are comparable or considered. We can call it as a massive structure. Any other example? Apart from dam, any other example? A retaining wall, perfect. It is an example for a our massive structure. Anything else? Yes, retaining walls or footings, you can say footings. These all are the examples for our solid structures. See, here we discussed about three classification or one classification of structures that is based on the dimensions, right? We classified it into skeletal structures, surface structures, solid or massive structures. I want to make one point clear here. We will be discussing about skeletal structures only in our syllabus. For our syllabus is confined only to our skeletal structures. In our GATE syllabus or in the thing you have studied till now, we will not be discussing about our surface structures and solid structures. Throughout the structural analysis, we will be talking about our skeletal structures. We have discussed about the example like frame, beam, arches, trusses, etc. All the structures we are going to deal with in our course of structural analysis will be of skeletal structures. And one more thing is there I want to discuss. I told you the dimension which is predominating in skeletal structures, it can be length, breadth, height, whatever may be. Our analysis, the structural analysis will be based on that dimension which is predominating. Okay, the analysis will be based on that dimension which is predominating. You have to write it. The analysis will be based on the dimension which is predominating. The structural analysis will be based on that dimension which is predominating. In simply supported beam, what was the dimension which was predominating? Length of the beam was predominating, right? The analysis will be based on length. Coming to column, which dimension is predominating there? Height of the column is predominating there. The structural analysis will be based on that dimension. You have to keep this thing in your mind. The analysis or the structural analysis will be based on that dimension which is predominating. I hope you have written it down. The structural analysis or the analysis of structure will be based on that dimension which is predominating. Okay, so as I told you, we will be focusing only on our skeletal structures. We are going to forget about these solid structures and surface structures. We are not going to deal with our solid structures and surface structures. We will be mainly focusing on our skeletal structures, or we will be only focusing on our skeletal structures, where we will be discussing or we will be studying various methods for analyzing our structures like frames, beams, columns, arches, trusses, etc. We will be discussing only about our skeletal structures. Forget about our solid structure, forget about our surface structure. We are not going to analyze our surface structures, and we are not going for the analysis of solid structures. Right? We will be discussing only about our skeletal structures. Got the point? I hope it's clear, right? Yes. So I'm taking our skeletal structures here. I told you our focus will be on our skeletal structures, and I'm going to classify our skeletal structures again based on the type of joints present in it, which is actually very important. Write down, based on the type of joints present, skeletal structures are classified into two. You can write down, based on the type of joints present in it, the skeletal structures are classified into two. First one, pin jointed structures, and second one, rigid jointed structures. The skeletal structures are classified into two, that is pin jointed structures and rigid jointed structures. I hope you are noting it down. Then I am asking you, can anyone tell me what is this basic difference between a pin joint and a rigid joint? Anyone? Yes. The skeletal structures are classified based on the type of joints present in it. First one is pin jointed structures and rigid jointed structures. I am asking you, what is the basic difference between a pin joint and a rigid joint? Anyone? What is a pin joint and what is a rigid joint? A roller. Okay, roller is actually a type of supports. We will come to that. Momentum is not zero in a pin. Moment is not zero in pin. Okay. Abhay. Okay. We will discuss it. Moment is zero in pin. Okay, let's discuss it. Then, yes, sir, no type of movement in rigid and only one side of movement in pin, Aditya. Okay, let's discuss that. Okay, see, just give the heading pin joint. Give the heading pin joint. I am talking about this pin joint first, and after that I will discuss about our rigid joint. See, if I take a structure, I am taking a structure like this. This is actually a frame. This is a simple frame here. I am trying to explain it in a simple manner. Okay, this is a member, this is our column, this is our beam, and this is our another column. See, these are members. Like one column is there, another column is there, one more beam is also there. This beam is connected. This beam is connected to this column with this joint. Or at this joint, this beam is meeting with our column. Here also this column is meeting with this beam at this joint. So some joints are there, correct? See, I am considering it as pin joints. I am talking about pin joint now. This is my pin joint. I am considering it as a pin joint. See, if I magnify this, how these members are connected together. When I magnify this, you will understand how these members are connected together. See, if these two are the members, you cannot connect it like this, na? There must be a proper connection between these members, right? If I magnify this, if I take it here, you can see like this. One member is coming. This is our beam. There is a continuation towards left, and one more member will be there. That is our column, and there is a connection towards downside. These two members actually is connected like this here, but this is not the actual case. These two members will be connected to a common plate which is called, anyone? These two members will be connected together to a common plate which is called, anyone? These two will be connected to a common plate which is called, yes, what is this plate called? Where the members, yes, gusset plate. Superb. The members will be connected to a common plate which is called our gusseted plate. I am taking it as GP, gusset plate. Okay, that means these members will be connected to this plate with a single pin or single rivet. Then I will call it as a pin connection, or I will call it as a pin joint. Where the members are connected together, so connected to a gusseted plate with a single pin or single bolt or single rivet, then I will call it as a pin connection. Then what is the specific or what is the speciality of this pin joint? This is also possible. This is actually one type of pin connection. Otherwise, this is also possible. This is our gusseted plate. This is our gusseted plate where the members are connected. This is our one member. This is our one member. The continuation is there. Other member is also there. And these two members are connected to the gusseted plate like this. This type of connection is also possible. But in pin connection, whether you can follow this or this, whatever may be, the members will be connected to the gusseted plate by using a single pin or single rivet or single bolt. You have to remember this in your mind. Only one bolt will be there for connecting these two members. Suppose this is one member, this is one member, and this is another member. This is our column and this is our beam. These two members will be connected together by using a single pin or single rivet. Then what is then you can tell the speciality, you can tell the property of this pin connection. See, if only one pin is there, this member can move in this way, this member can also move in this way. That means free rotation is possible. This member can also rotate, this member can also rotate. Can you just tell me whether this rotation and this rotation is same? Will this rotation or the rotation of this member and the rotation of this member is same? When it is connected with only one pin or one rivet, will the rotation be same? No. No. The rotation here will not be same. See, some of you are saying yes, yes, yes. Okay, we will discuss it. See, these two members are there. You will understand this when we talk about our rigid jointers. When there is a pin connection, one member will be connected to other member, but these connections will be done with a single pin or single rivet. When we use a single pin or single rivet, the rotation of this member will be different. Rotation of this member, rotation of these two members will be entirely different to each other. Or I will say the rotations will be independent to each other. I will tell you, I will explain in a different way. See, if I take this beam here, if I take this member here, this is our beam, this is our column. Independent rotation means when some moment is acting at its joint, what is going to happen? The member here is going to rotate. Suppose one clockwise or anti-clockwise rotation is there. Suppose one anti-clockwise rotation is acting at this joint or acting on this member. This member or this beam is going to rotate. I am considering it as theta. Then this column will also rotate. This column will also rotate. I am considering this also. I cannot consider this also theta. Why? Because at a pin connection, the rotation will be different. The rotation in this joint at this beam will be theta 1. The rotation of this column will be theta 2. These two members are going to deflect or rotate in a different manner. That means you will be having independent rotation. Independent rotation. At a pin connection, you will be having independent rotation. That means if I have a member like this is our beam, this is our column. The beam is going to rotate with an angle theta 1 and the column is going to rotate with an angle theta 2. The rotation of these two members will be different or independent rotation will be there at our pin connection. You can write it down. Write down in pin connection or in a pin joint. In a pin connection or in a pin joint. In a pin connection or in a pin joint, the members will be connected by using a single pin or a single rivet. The members in a pin joint or pin connection will be connected together by using a single pin or single rivet. Right? Second point will be the rotation of the members meeting at that pin joint. The rotation of that members meeting at that pin joint. The rotation of the members meeting at that pin joint will be different. Or independent. The rotation of the members meeting at that pin joint will be different or independent. You can draw these figures. The theta here in this member will be different and the theta here in this member will be different. Theta 1 and theta 2. I hope it's clear. right? This is actually what is pin joint. In pin joint, the members will be connected together using a single pin or single rivet, or this is also possible when two members are connected together by using a single pin or single rivet. When bending moment or when rotation is acting on this members, what will happen? This member will rotate in one fashion and this member is going to rotate in a different fashion. Theta will be different. Theta will be different. I hope it's clear. Shall we go for rigid joints? Shall we go for rigid joints? Yes, pin and rivet can be considered as the both will convey the same meaning. Okay. Yes. Yes, we are moving on to rigid joints. Now you got the concept, I guess. I think the concept of pin joint is clear to you. We are going to our rigid jointed connections. See, I am taking the same member here. I am going to take the same frame here. One column is there. This is our column, and there is our beam here, and our second column. I am considering this as our rigid joint. This is not our pin connection. This is our rigid joint. I am going to magnify this joint. Like one member is connected here, this is a beam and this is a column, and that's the meaning of this. I am going to magnify this. How it will be? As I told you, these members, we cannot connect the members like this. We need a gusseted plate for the connection. One member, this will be our beam, this will be our beam, and this will be our column, right? This will be our beam and this will be our column. These two, that is column and the beam, will be connected together in a plate called gusseted plate, right? Or gusset plate or gusset plate. This will be connected together in a gusset plate. Here the difference is, here the members was connected to the gusseted plate by using a single pin or single rivet or single bolt. Then tell me, in a rigid jointed connection, how the connection will be? How it will be connected? Yes, we will be using more than one rivet, or we will be using more than one bolt, or we will be welding will be preferred for connecting the members to the gusset plate. We will be using more number of bolts or more number of rivets, or you will be preferring welded connection for connecting these members to the gusset plate. See, this is possible, otherwise this is also possible. One member, this is our beam and this is our column. One beam and one column, both will be connected to a gusseted plate. This is our gusseted plate, gusseted plate, gusseted plate. These two will be connected by using one beam will be connected like this, column will also be connected like this. Both will be connected by using welded connections, or different number of bolts or rivets will be used. Tell me, what is the speciality of rigid joint? Here the rotation of this beam was θ1, rotation of the column was θ2. That means the rotations was independent here in this pin connection. Then coming to a rigid joint, as the members are connected together by using more than one rivet or more than one bolt, or it is welded or welded connection was preferred in rigid joint, the rotations will be, is it independent or it will be dependent? Yes, same rotation will be there. Dhruv, go, right? I think it's Dhruv. The perfect answer is the rotation will be same. The rotation of this member and the rotation of this member will be same. The rotations will be independent. Perfect answer. See, the members will be like this. It was a pin connection. Only one joint was there. Only one rivet was there. It was connected like this, and the rotation was there. One member and another member. The rotation was independent there. But in coming to our rigid joint, one member will be connected to other member. There is a perfect bond between these two members, or the joint here is perfectly rigid. Suppose some bending moment or some rotation is happening at this joint, what will happen? The entire connection, entire joint, or all the members meeting at that joint is going to rotate together. The rotation in this beam and the rotation in this column, you can see it here, right? This is our beam and this is our column. There is a perfect connection. There is a rigid joint. The members, beam and column are going to rotate with the same angle. The rotations are same. Or the rotation will be same in all the members meeting at this rigid joint. Suppose the rotation here, if I am taking it as theta, here it will be theta. Alright? These both the members meeting at that joint will be rotating with the same angle. You have to remember this. the rotation of the members meeting at a rigid joint will be same throughout. Right? The theta is the rotation in one member. The other member will also have a same rotation, that is theta. Got the point? Got the point? If you want more examples, suppose I am using this page here. Suppose there is a structure like this. There is one end is fixed. Here also we have a fixed end. Here we have a hinge support. Here we have a fixed end. Suppose you are trying to rotate this, okay? You are giving a moment at this joint. I am taking this joint as O. You are just trying to rotate this joint, okay? If I am applying a moment here, if you are applying a moment here, you are applying a clockwise moment here at this joint. What is going to happen? This member will rotate like this. This member will also rotate like this. At the fixed support, rotation will be 0. There will be moment of resistance will be there. Rotation will be 0 at a fixed end. That's why it is drawn like this. That means slope here it will be 0. Then coming to hinged end, it is also going to rotate like this. Here some rotation will be there. Here also some rotation will be there. Then coming to this fixed end, here also some rotation will be. The rotation here is 0. As it is a fixed end. The entire part of the part of the structure is going to rotate. At this joint, it is going to rotate. This member will rotate. This member will rotate. This member will rotate, and this member will also undergo some rotation. So that means if it is a rigid joint, I am talking about rigid joint here. If it is a rigid joint, the rotation of all the members will be same or different. If it is a rigid joint, the rotation in all the joints will be, so all the members will be same or rotate. So same or different? Yes. If it is a rigid joint, all the members meeting at that joint is going to rotate with same angle. That means this will be theta, this will also be theta, this will be theta, and this will also be theta. That is the specialty of our rigid joint. In a pin connection, rotation was independent. In rigid joint, the rotation was dependent, or the members meeting at a rigid joint is going to rotate in a same manner. You have to understand this concept. This is a very, very important concept. In a rigid joint, the members are going to rotate in a same manner. Okay? Is it clear? Is it clear? And one more thing is there. If it is a rigid joint, suppose it was the angle. Suppose it was 90 degree. And here also it was 90 degree. It is a rigid joint. Okay? I am talking about a rigid joint now. Now you can see the red line. That is a deflected profile. That is how it is deflected. The black line was actually our original beam, original structure. Then after rotation, it became like this one. That is our red line. Okay. See, if this was theta, if this was 90 degree, after rotation, what will happen? After rotation, what will happen? The internal angle is not going to change. That means the angle of the joint or angle of the member before rotation will be same even after rotation. Are you getting my point? If it is a rigid joint, if 90 was the initial angle, even after rotation, the angle will be same. Why? Because both the members are rotating with same angle. But in pin connection, it is not the same. Here the rotation here it is. Here the rotation here is dependent. That's why it is called dependent rotation. The internal angle of the members will be maintained. The angle between the members will be maintained. So that's the basic difference between a pin jointed structure and our rigid jointed structure. I hope it's clear, right? Is it clear to you? The difference between pin joint and rigid joint? You have to understand this. It's a very important concept. A rigid joint and or a pin joint. You have to understand this difference. Yes, it is. It means that Amit Verma is saying that it means that member rotate in opposite direction. That's actually not clear to me. Can you ask me that clearly, more clearly? I need more information there. It means that members rotate in opposite direction. No, actually, I hope you are talking about this or this, whatever may be. If the rotation is anti-clockwise, if I am applying a moment in the anti-clockwise direction, this member will go in this direction and this member will also go in this fashion. If the rotation is clockwise, if the rotation here is clockwise, if I am applying a rotation here in the clockwise direction, this member is going to rotate like this member is going to rotate like this. Here I applied a anti-clockwise rotation like this. That's why the members are rotating like this. I hope it's clear now. Right? Shall we move further? Yes, I'm moving further. I hope you have noted these things down now. Yes, I was actually classifying the joints, so classifying the skeletal structures, right? I told you that we'll be discussing only about our skeletal structures, and I classified the skeletal structures based on the type of joint present in it, that is pin jointed structures and rigid jointed structures. Again, we can classify further. The pin jointed structures can be again classified into two, that is plane frames and space frames. A rigid jointed structures are also classified into two, in the same manner, plane frame and our space frame. Plane frame and our space frame. It will become pin jointed plane frames, pin jointed space frames. Correct? This one is our rigid jointed plane frames and rigid jointed space frames. Rigid jointed plane frames and rigid jointed space frames. This one is our pin jointed plane frames and pin jointed space frames. See, this classification is actually very much important. Our first chapter will be degree of static indeterminacy and degree of kinematic indeterminacy. Further, we will study various methods for analyzing structures. All the analysis or finding degree of static indeterminacy and finding degree of kinematic indeterminacy, all those things will be based on this classification. We will be studying how to find the degree of static indeterminacy for a pin jointed plane frame, for a pin jointed space frame, rigid jointed plane frame and rigid jointed space frame. See, this pin jointed plane frame, you can call it as plane truss also, but there is actually difference is there. Pin jointed plane frame and plane truss, there is actually some minute differences there. You will understand this when we study the chapter analysis of trusses, but for now you can understand like this: pin jointed plane frame or plane truss. Similarly here, space frames are also called as space truss. Space truss. Coming to your rigid jointed plane frame, you will be having beams there, you will be having your frames there, you will be having arches there. Different classifications or different type of structures are available there, like beams, frames, arches, etc. Alright? Yes. Fine, you can note this down. Pin jointed plane frame, pin jointed space frame, a rigid jointed plane frame and rigid jointed space frame. Yes. One more thing is there. Actually, I wanted to mention one more thing. We discussed about pin connection, right? We discussed about pin connection or pin joint. We discussed about rigid joint also. One important point is also there. You have to remember this also. For a pin joint, see, if there is a pin joint, the pin joints can transfer mainly our axial forces. The pin joint is not going to carry the bending moment. What cannot carry? It is not going to carry the shear forces. It is going to carry the axial forces to this joint. The pin joint is going to carry the axial forces, and the rigid joint will carry the shear force, bending moment, and axial forces. Right? You have to note that down also. Like for a pin joint, write down for a pin joint, it can carry axial forces only, and a rigid joint can carry axial force, shear force and bending moment. Axial force, shear force and bending moment. Pin joint will carry only axial forces, and the rigid joint will carry axial force, shear force and our bending moment. You have to remember that also in our mind. Okay, this is actually the basic classification of our skeletal structure. We are going to classify the skeletal structure based on the type of joint present, that is pin jointed structures and rigid jointed structures. Pin jointed structures are again classified like pin jointed plane frames, pin jointed space frames, rigid jointed plane frames and rigid jointed space frames. You have to keep this classification in your mind. Our entire analysis part will be based on this classification. Okay, I am going to write this classification just there, towards the side of the board, or on the side of the board, for your proper, it's needed to us. Okay, needed for us. I'll be writing it here. That is pin jointed structures were classified as plane frames and space frames. The rigid jointed structures will be classified like plane frames, that is rigid jointed plane frames, and our rigid jointed space frames. Okay, let it be there. You will understand the importance of that. Then after that, yes, fine. See, we will be writing the definition, so writing the classification there. Actually, we needed that further. Actually, Aditya is telling that repeat. I think the past one, right? I was telling like the pin joints will carry the axial forces, and the rigid joints will carry the axial force, shear force, and our bending moment. Okay, you have to remember these two things. That is our pin connections and rigid connections. In a pin connection, the rotations are independent and the members are connected together at a pin joint with a single pin or single rivet, and the rotations are independent there, and the pin joints can carry only axial forces. Coming to the rigid joint, the members they are connected together by using more than one bolt or more than one rivet, or the members are welded there. Their rotations are dependent there. The rotation in one member will be equal to the rotation in the other member. And one more thing I discussed there, the rigid joints can carry the rigid joint can carry our axial force, bending moment, and our shear force.